Two equal charges, Q, are positioned at points x equals L, comma, y equals 0, and x equals negative L, comma, y equals 0. Part A asks to determine the electric field as a function of y for the points along the y-axis. Part B asks to show that the field is maximum at y equals L, or plus or minus L, over square root 2. So I first drew a picture here, labeled the points Q at negative L, comma 0, and Q at L, comma 0. I labeled this point right here O, which is r distance away from the midpoint, which is the point right here, which is P. Here's theta, and here's theta, which are equal to each other. E1 and E2 represent the electric field at the point O due to the two charges Q and Q. First, I used E1 and E2 and split them up into two components, the parallel component and the perpendicular component. The perpendicular component was E1 sine theta and E2 sine theta. Those cancel each other out because they're equal and opposite. So left we have the parallel components, which were E1 cosine theta and E2 cosine theta. The parallel components are in the same direction, hence they add up. So the resultant right here is E equals E1 cosine theta plus E2 cosine theta, which is the resultant of the electric field at this point O. Using Coulomb's law, which states that F equals K times Q1 times Q2 all over R squared times the vector of R. Plugging in these values, we have E equals K times Q over R squared plus L squared plus Q over R squared plus L squared times cosine theta. And this right here is E1 and E2. If R is greater than L, we can ignore L squared in this equation right here and only pay attention to the R squared. So rewriting this, E equals Q over K, all multiplied by 1 over R to the third, or rewriting this again just a little bit of a different way, 1 over K multiplied by Q over R to the third. So all in all, the direction of the magnetic field is parallel to the axis of the dipole from positive charge towards negative charge. Part B asks to show that the field is maximum at y equals plus or minus L over square root 2. When L equals L over square root 2, we can use this equation right here. E equals K times 2 times Q times L all over L divided by square root 2 to the third power. Rewriting that, we get E equals K times 4 times square root 2 times Q over L squared. That is the maximum value of the electric field. Therefore, the answer to part A was that the direction of the electric field is parallel to the axis of the dipole from positive charge towards negative charge. The answer to part B is that the field indeed is a maximum at y equals plus or minus L over square root 2.